Imagine you're the IT director for a cancer research facility at a major university, where you're responsible for managing dozens of petabytes of imaging files. One of your remote research teams has asked you for help with a new project. They've developed a cloud-based AI engine that can detect breast cancer tumors in medical images, and they'd like to validate it against some of your existing image data. Timelines are short. They have 24 hours to test their algorithm in AWS, but all your image files are stored on premises. There won't be enough time to move 100 terabytes to AWS before testing needs to begin. But with all your images hosted on a Qumulo cluster in your data center, you can deploy a cloud-native Qumulo instance on AWS that's visible to your team's AI engine, and then use Qumulo's new Cloud Data Fabric to make those image files available for scanning. Where any other approach would require expensive or time-consuming replication tools to move thousands of files to AWS and take hours to days before they're usable, Qumulo's Cloud Data Fabric can be deployed and ready to go in less than 10 minutes. It's simple to deploy and flexible enough that you can customize it for your specific workflows using the EC2 configuration that meets your unique performance and cost requirements. For our AI workload, we've configured our CNQ with 3 i4i 8x large EC2 instances. Once that's ready, we can connect to the new CNQ instance via the web UI and configure and manage it just like any other Qumulo storage cluster. We can also connect to its default SMB share from the Windows client on AWS that manages the AI engine. You can see that there isn't any data available locally, yet. For comparison, here's the share on the Qumulo cluster in our data center that holds our images. If we look at the share's contents, we see a lot of folders containing a lot of files. And now that CNQ is live on AWS, we can add a Cloud Data Fabric portal that links back to our on-premises cluster in just seconds using Qumulo's rich API command library. The new portal will make the remote share visible to any AWS client, including the AI engine, as if it were local. Now that we've created the portal, the AWS client can see the image files from the physical cluster through a local mount point. If we zoom in, we can see that the data is the same, even though the mount paths are on different clusters. In less than 10 minutes, we've gone from a single physical Qumulo instance in our data center to a hybrid cloud data fabric containing thousands of image files that our AI algorithm can begin scanning immediately. Our Windows client can immediately see the entire tree structure because the portal's metadata moves between endpoints in real time. We can confirm this by checking the CNQ instance's web UI, where we see that so far only metadata from the portal is being stored locally. None of the file data has actually moved yet. But with the files we need now visible to our AI engine, we can start scanning the images as if they were on the local Qumulo instance. And as the AI engine scans our image files, it flags tumors as it finds them, assigning a confidence factor to each image which is logged in a CSV file that's saved on the local end of the portal. Cloud Data Fabric portals can be bidirectional, so once the job completes, the finished CSV file is immediately visible to clients and workflows at the other end. In this case, by the research team accessing the physical Qumulo cluster in our on-premises data center. For every remote file accessed across the portal, Cloud Data Fabric saves it in cache on the local endpoint. If we watch the CNQ instance's web UI during our AI run, we can see the capacity number increasing. And the next time a client or workflow needs these files, they'll be served from the local cache rather than pulled across the WAN again. Unlike wholesale replication solutions, Cloud Data Fabric uses client activity to determine which data to synchronize between Qumulo endpoints. Cloud Data Fabric minimizes replication traffic across your WAN links by synchronizing only new and changed data sequences rather than whole files or datasets. And it doesn't only work for medical imaging. You can use the same bidirectional portal features to accelerate genomics research by ingesting in one site and analyzing in another. With support for multiple spokes from a single hub, Cloud Data Fabric can enable remote collaboration even in a multi-cloud enterprise, unifying edge, cloud, and data center workflows into a single shared portal. By pairing cloud-native Qumulo with Qumulo's Cloud Data Fabric, you've provided your research team with the validation they needed, giving them immediate access to thousands of image files and enabling new cloud-based artificial intelligence. Imagine what else you can do with it. To learn more about Qumulo Data Fabric and cloud-native Qumulo and how they can accelerate your healthcare and life sciences workflows, visit Qumulo.com or contact your Qumulo representative today.